Find the absolute extrema of the function on the closed interval. We are given this function f of x equals 2x squared minus 8x. And what we're trying to do is we are trying to find the absolute maximum and the absolute minimum on this interval, 0 to 6. When you do this, you need to find the critical values. And the critical values are the values of x that will make the derivative equal to 0, or the values of x where the derivative is undefined. So in order to complete this exercise, we need to first find f prime of x. Just by using the power rule, we get 4x minus 8. And what we really want to do here is set this equal to 0 so we can find the values that will make the derivative equal 0 when we substitute them in. When we solve for this, we get x equals 2. When we get an answer, it is important to check that this number is in fact in this interval. And yes, x equals 2 is in this interval. So the last thing we need to do is check our endpoints and our critical value in the original function. So f of 0 is, f of 2 is, f of 6 is. When you substitute these numbers into the original function, we get 0, -8, and 24. Then out of these numbers right here, we just need to pick the maximum and the minimum numbers. This is the smallest number, so here is your minimum. This is the biggest number. Here is your maximum. For this next example, we are being asked to do exactly the same thing. Find the absolute extrema for the function on the closed interval. This derivative will need to use the quotient rule. So when we find the derivative of this thing, you will get g prime of t equals t squared plus 3, that's the denominator, times the derivative of the numerator, minus the numerator times the derivative of the denominator all over the denominator squared. As we simplify this, you can distribute the 2t here to the t squared and to the 3 and multiply this out and then subtract accordingly, and you will get 6t over t squared plus 3, the quantity squared. And with this denominator, you can set it equal to 0 and solve for t, but you will find that you will get no restrictions, because if you set this equal to 0 and solve for t, you will get imaginary answers. So there are no restricted values here for this function as far as the derivative is concerned. So when we set this equal to 0 and solve for t, we'll simply get that the 6t in the top equals 0. Right, multiply both sides by this, and you'll get that t equals 0. The interval we are working on goes from -1 to 1. Now that we have all of the critical values being t equals 0, we will check that critical value in these endpoints in the original function to see what the max and min are. And it's good to note here as well that this 0 value is inside this interval, so yes, we need to check this 0. So when we look at g of 0, the original function, you get 0. When you look at g of 1, you get 1/4. When you get g of -1, you also get 1/4. So in this case, we have a minimum here and two different parts that have a maximum. You're allowed to have more than one maximum location. We have the same maximum value of 1/4, and it just happens to be a maximum value in two different spots, when x equals 1 and when x equals -1. One last example, this will be a setup only. We have the equation y equals 3x to the 2/3 power minus 2x. If we find the derivative of this, we get y prime is 2 over x to the 1/3 power minus 2. And this is all happening on the interval -1 to 1. You'll notice here that we have an x in the denominator. So when we find out what the restricted value is here, we take the denominator, set it equal to 0, and get x equals 0 after you cube both sides. This is where y prime is undefined. So since y prime is undefined, this is the other section to the critical values, or the critical numbers. It happens when you set y prime equal to 0 and solve for x, and where the derivative is undefined. So this value is a critical number, and it is in the interval -1 to 1. I urge you to try the rest of this problem yourself, and you should get some answers that look like the following. F of 0 is equal to 0 is your min, and f of -1 equals 5 is your max. Good luck.